Special angles notes continued. Remember the special angles that are formed by parallel lines. Remember that parallel lines never intersect. They are always the same distance apart between the two lines. Remember that perpendicular lines intersect at right angles. Remember that the transversal is a line that intersects parallel lines. Remember that it is the other line other than the parallel lines. Remember that alternate interior angles mean opposite and inside, opposite of the transversal, but inside of the parallel lines. For example, D and A are both inside the parallel lines, but on the opposite side of the transversal. And C and B are both inside the parallel lines, but on the opposite of the transversal. Remember that alternate exterior angles are opposite of the transversal, but outside the parallel lines. Just like 2 and 7 are the opposite of the transversal, but outside the parallel lines. And 1 and 8 are opposite of the transversal, but outside of the parallel lines. Remember that corresponding angles are on the same side of the transversal. One is inside the parallel line and the other is outside, like D and H, or B and F, or A and E. Remember that vertical angles are two angles that share a vertex but no side. Remember, they are the V's that point at each other and only meet at the vertex, or one point. It would be A and A, or B and B. Using what you know about angles, see if you can find the measure of the other angles if the measure of angle 1 is 130 degrees. Then, what would be the angle measure of 2? You should notice that they together make a straight line. And a straight line is 180 degrees, so you just need to subtract 180 minus 130, and you will get that measure of angle 2 is 50 degrees. If the measure of angle 1 is 130 degrees, let's find out what the measure of angle 3 is. Angle 3 also will form a straight line with angle 1. And we know a straight line is 180 degrees, so if you subtract that from 130 from 180 degrees, you will get that the measure of angle 3 is 50 degrees. Again, if the measure of angle 1 is 130 degrees, we can find the measure of angle 4. Angle 4 makes a V that points at 130 degrees of the measure of angle 1, and they share a vertex, so we know they're vertical angles, so it's equal. So the measure of angle 4 would be 130 degrees. Again, the measure of angle 1 is 130 degrees, so now let's find the measure of angle 5. Angle 5 is on the same side of the transversal line, but angle 5 is inside the parallel lines while angle 1 is outside. That means angle 1 and angle 5 are corresponding angles and are the same measurement. So angle 5 will also be 130 degrees. Again, if angle 1 is 130 degrees, we can find the measurement of angle 6. Now, if you remember, we already did the measure of angle 2, and it found that that was 50 degrees. Now look at the blue lines. Angle 2 and angle 6. They are on the same side of the transversal line. One is inside the parallel lines and one is outside. So we know that angle 6 and 2 are corresponding angles and are equal to each other, and angle 6 is 50 degrees. Now, knowing that the measure of angle 1 is 130 degrees, let's look at what angle 7 could be. If you remember, we have already gone over the measure of angle 3. Angle 3 was 50 degrees. And if you look at the blue angles, angle 3 and angle 7 are on the same side of the transversal. One is inside the parallel line and one is outside. So we know those two blue angles are the same and that angle 7 would be 50 degrees. Again, angle 1 is 130 degrees, and we want to find out what angle 8 is. If you notice, they are on the opposite side of the transversal, and they are both outside the parallel lines, which means that they are alternate exterior angles, and that means they are equal. So we know angle 8 is 130 degrees, just like angle 1. In the next set of questions, we're going to look at the measure of angle 1 with algebra, 2x plus 20. And the measure of angle 5 is going to be 100 degrees. So first, if you write that in, angle 1 is 2x plus 20, and angle 5 is 100 degrees. You can look and see what kind of angles are they in relation to each other. You'll notice that they are both on the same side of the transversal line. One is inside the parallel lines, and one is outside. This means that they are corresponding angles and are equal. So because of that, we can set 2x plus 20 equal to 100 degrees. And then you solve for x. Undo the addition by subtracting 20 from both sides, and that will leave you with 2x equals 100 minus 20 is 80. Then undo the multiplication by dividing by 2 on both sides, and that leaves x equals 80 divided by 2, which is 40. So now we can plug in and find the measure of angle 1. The measure of angle 1 is 40 times 2 plus 20. 2 times 40 is 80, and 80 plus 20 is 100. So we know that angle 1 is 100 degrees, and angle 5 is 100 degrees. Now to find the measure of angle 2, you can look at how we already know 100 degrees is angle 1, and angle 1 and angle 2 make a straight line. So a straight line is 180 degrees, and if you subtract angle 1, which is 100 degrees, you will find that angle 2 is 80 degrees. So we found that angle 1 was 100 degrees and angle 5 was 100 degrees. Now we want to find out what the measure of angle 3 is. Angle 3 makes a straight line with angle 1. So to find angle 3, we can simply subtract 180 minus 100, and we get 80 degrees, and that means that angle 3 is 80 degrees. So now we know angle 1 is 100, angle 3 is 80, and angle 5 is 100. And now we want to find out angle 4. Angle 4 makes a vertical angle with angle 1 because they both have V's that point at each other and meet at the vertex. That means angle 4 and angle 1 are going to be equal, and angle 4 will be 100 degrees. Now that we know angles 1, 4, and 5 are 100 degrees, and angle 3 is 80, now we can find out what angle 6 is. Angle 6 actually forms a 180 degree straight line with angle 5. So you could find it that way. Angle 5 is 100 degrees. If you subtract it from 180, you would get that angle 6 is 80 degrees. The other way you could have found it out is if you looked at So now we know that angle 1 is 100, 2 is 80, 3 is 80, 4 is 100, 5 is 100, and 6 is 80. We can find out what the measure of angle 7 is. You can do this a few different ways because you know so many angle measures already. The first way you can do it is looking at angle 6, which is 80 degrees, is a vertical angle for angle 7. So that means it would be the same as angle 6. You could also look at it as angles 5 and 7 make a 180 degree angle. So you start at 180, subtract angle 5, which is 100 degrees, and you would get the answer for 7. And you could also look at angle 2 and angle 7. They're on opposite sides of the transversal, and they are both outside the parallel lines, which means they're alternate exterior angles and they would be equal. No matter how you find it, you should figure out that the measure of angle 7 is 80 degrees. And now to find the measure of angle 8. Again, we have all of these angles we know already, so there are multiple ways that you can find this. The first thing you can look at is angle 5 and angle 8 make vertical angles where they only touch at the vertex, so they would be the same. You could also look at angle 4 and angle 8, and you'll see that they are on the same side of the transversal, but one is inside the parallel line and the other is outside the parallel line. That means that they are corresponding angles and would be equal. You could also look at angle 7 and angle 8 make a straight line, which is 180 degrees, and subtract 180 minus 80. And you could look at angle 1 and angle 8. They're on the different side of the transversal line and on the outside of the parallel lines, which makes them alternate exterior angles, and they would be equal. Either way you find it, you should figure out that angle 8 is 100 degrees.